everyone. This is a lesson 22. Okay, so today, area under the curve. Let's take a look. Here, this will lead us to fundamental theorem of calculus and an amazing application of antiderivatives. So we are going to learn the fundamental theorem of calculus next time. Okay, before that, let's understand what the antiderivative does. All right, so we learned last time how apply the antiderivative, right? So undo from the derivative, right? Okay, today, look, we have to find the area of the rectangle. So how they find area of rectangle, right? So we know the length times the width, right? So in that case, they're using h as the height and b as base. So area, which is height times base, right? Here, the middle one looks like a square, right? So even square area is one side and then times the other side. Then here area, the last one. So base times the height. In that case, is x times f of x, right? So if we have a function, this one is x-axis, then if we have function, there will be height, right? So that is the function notation, same as height. Then we had x, then that will be same as base. Okay, base we can use as a width, right? Okay, now they say that what do you get when you multiply a rate by quantity with the same units as the denominator? A quantity with the same units as the numerator. So this is a denominator. Oh, sorry. So this is a denominator. This is a numerator. So we have a quantity, same unit with denominator. Then we can simplify. Then we have $100,000. So we are using only the unit from the numerator, right? So same as here. So we have miles. Same as here, we have 150 tons. Okay, now we have this one. All right, so how do you find area? Okay, so I want to write down this way. Draw, not to write down. I want to draw this way. And this way. This way. And this way. Okay, later let me pause and then we draw everything. Okay, then we can see there is a rectangle, right? All right, then what is the area? So we want to know about how much coal in tons was mined in the first 6 weeks. So I made the rectangle until 6 weeks. Yeah. Then what's the area? So area equal to the base times the height. In that case, is x times f of x, right? So this is x. This is x. This is f of x, right? Or we can say the y. It's okay too, y, right? So we had x times y earlier, and then we had x times f of x. We had a base times y, right? Same. Everything's the same. Okay. Then the area, let's denote A, right? Then x times the height. Maybe base times height, yeah? Base times the height. Okay, then in that case, we have x times height will be f of x, or we can denote as y, right? All right, so this x, what's the base or width? Same thing. This is 1, right? So from here to here is 1. So we denote 1 height. So this is a function, but then we can just using the graph. So f of 1, that's the height, right? So in that case, we have 91. Can you see that? That's the first rectangle, right? How about second rectangle? We added them. What's the base? Base, which is width, which is 1 as well. Then height will be f over 2. F over 2, I am reading here 83. We added them. And 3. So base, which is width, equal to 1. Then we have 1 times f over 3, which is, I am reading this one, 75. And same as f over 4. Oh, we need more, right? 6 until 6. Let me do this one here. So we have 1 times f over 4, which is 68, plus width 1 and f over 5, which is 62, 1 times, and plus 1 times f over 6, we done, right? And then f over 6, which is 56. All right. This one, we add everything because 1 times doesn't do anything, right? So we have a 435. Make sense? Yeah. So basically, we add each rectangle, then we get the area. All right. Now, same stuff, right? What if I draw the rectangle this way? So I want to draw a rectangle. Ooh. Right, this way. And then let me pause and then I'm gonna do that, right? Okay, so I draw every rectangle there. So a little bit different shape with the before, right? Okay, so then same calculation. So area of a rectangle is base times the height or width times the height. So let's do that. So we have area A equal to width times height. How about that, right? So there will be this width, which is 1 times height, f of, how about 0? Yeah, instead of start to f of 1. So f of 1, I'm sorry, f of 0, which is 100. So we have 1 times 100. Then plus second width, 1. So 1 times f of 1, which is 91, plus 1 times f over 2, the next, then f over 2, which is 83, plus 1 times f over 3, plus 1 times f over 3, which is 75, plus 1 times f over 4, which is 68. So let me make a little bit smaller here. And then we have plus 1 times f of 5, 0, 1, 2, 3, 4, 5. Okay, I want to stop there. So plus 1 f over 5, which is 62, right? 1 times. Okay, so if we multiply 1 times, doesn't do anything. So we add everything up, so we get 479. All right, so let's compare this area. We draw this way under the curve of rectangles. Then we have a 435 in tons. The coals, right? And here we have in tons. But then let's take a look at the units, right? So this is a tons per week. And we have a number of weeks, right? So long, if we factor out 1, that's the number of weeks. Yeah, every x values is number of weeks. Then we can simplify. Then we get in tons, right? So in tons. Okay, so you guys okay with this? One is the less than, I mean the under the graph, the draw the rectangle. And this one above graph, we draw the rectangle. Okay, so we found the cost in tons, right? In the first weeks. Okay, now we have this one. Same, we have a same, the function, right? We want to estimate the tons of calls mined in the first 6 weeks by computing and summing area of rectangles. Summing areas. We had the first rectangle, second rectangle, third rectangle, fourth rectangle, fifth rectangle, right? Okay. Now they give us 3 sub intervals and then right hand endpoint. Okay. So let me explain to you what this means. We have first 6 weeks. This means x is between 0 to 6. Yeah. And then we have 3 intervals. That means, I mean, sorry, 3 serve, not serve, sub interval means. So we want to divide, right? So here, 6 minus 0, that's 4x, yeah? Over 3, I am using sub interval there. Then we have 2. This will be width. Okay? You guys okay? What we are using this one, right? 2 is there. Okay, so 2 will be width, which is base. And then they say the right hand endpoints means, look, I'm gonna draw right hand end point. So 2 is interval. Right hand, so right. So this point, right hand here, 63, that would be right hand. And then we will get the width like earlier, right? So this is x width. This is f of x, which is the same as y. Yeah. Okay, width 2, width 2. Okay, then this is a right end. Ooh. Right hand. And this is a right hand. Can you see that? The point, this point, this point, this point. Make sense? All right, let's do it. Let's do here because I don't have a space. So area, which is width times the height. So width in the case is 2. Then height will be f of 2, right? F of 2. 2 times f of 2. What do you get? F of 2, which is 83 plus width is 2. So 2 times f of 4 and plus 2 times f of 4, which is 68. And 2 times width 2 and f over 6 until 6, right? So we have a 2 times f over 6, which is a 56. Right? Okay. Okay, so then look, every term has a 2, so we can factor out 2. So 83 plus 68 plus 56. If we calculate this is 414. Okay, let's do let's take a look the other one, they say that 3 subintervals and left hand endpoint. So how do we draw? We draw this way. So width will be same because they have 3 subintervals, right? Okay, now left hand, so start here and 2, right? And start here, left hand and 2. So start here and here, right? Oh, I should do it using different color. Okay, so just using here. Area equal to width times the height. So width, we know that 2, right? Okay, then we start 0, the first one, because the left hand is started this one first. Then this one, yeah. Okay, now 2 times f of 0 plus 2 times f of 2, 2 times f of 4. That's it. We don't go more further. F of 6 because f of 6 is a right end point, right? Okay, then 2 times f of 0, which is 100, plus 2 times f of 2, which is 83. And 2 times f of 4, which is 68. Then we can factor out the 2, then 100 plus 83 plus 68, which is 502. You guys okay with this? All right. How about this? So we have 6 subintervals and right hand endpoints. Okay, let's do it. So x, so 6 minus the maximum of x and minimum of x, 6 minus 0. And how many we want to make intervals, so divide by that, right? So it's a 6, which is 1. Then this is the same as what we did earlier, right? Okay, let's do it. Right hand, this will be width. So right hand end, this is, I need the time, so let me make a pause. Okay, I draw everything. So area, what we did earlier. So area equal to width times the height. So everything is 1, right? So we can factor out with 1. Then f of right hand, so right hand started this one. That, right? So there will be f of 1 plus f of 2 plus f of 3 plus f of 4 plus f of 5 plus f of 6. Okay, so there will be, let me see. 1 times, we don't have to do, so f of 1, which is 91, plus f of 2, 83, plus f of 3, 75, plus f of 4, 68, plus f over 5, which is 62, plus f over 6, which is 56. Then we get 435. Okay, how about the right-hand side one? So we have to do 6 subintervals, left hand endpoint. Okay, then width will be same, 1. Then left hand left hand endpoint means we start the left. Yeah, so this way. And then, right? Okay. Let me pause again. Okay, so we have A equal to width times h. So there will be 1 times left hand. So we start the 0 first, x equal to 0. So f of 0 plus, how about 1? We can factor out. So f of 1 plus f of 2 plus f of 3 plus f of 4 plus f of 5. Okay, let's take a look here. So left endpoint is this one, this one, this one, this one, this one, this one, right? We don't do that. We don't do this one because this is the right hand point, right? In the rectangle, right? So left hand. Can you see the difference between there? Okay, then this is the same as earlier. So let me using earlier. We had 479. Yeah, this is the same as this is 479. Makes sense in tons, right? So everything is in tons. Okay, now then maybe we notice that note right endpoint, right hand endpoint. Right hand endpoint. So we finish the last endpoint. Use the last endpoint. Means that here, 6 here, right? For the x. How about left hand endpoint? Then think, use the first endpoint, right? So here, x equal to 0. Is it a little bit clear to you? Okay. So let's do this one. We have the function and then 4x minus x squared. Aha, I brought the picture for you here. So from 0, x equal to 0 to 2, and then we want to make 2 sub-intervals. Okay, then we have 2 minus 0. We are using that. And then how many we make sub-intervals? It's 2, so divide by that. Then we get 1, right? So this will be width. Okay, let's draw rectangle so that we can calculate easily, right? All right, they say that right hand endpoint. Okay, so let me draw. Uh, one, right? So one. Right hand. One. That's it, right? Because of between x to 2, yeah? So right hand, this is the right hand endpoint. Yes. Okay. So first one, we want to know about the area, then width times height. So width is one, right? So one doesn't do anything, even though we factor out. And then height will be f of x equal to y, same thing. So one, then right hand endpoints, we start to f of 1 plus f of 2. That's it, right? 1. What's f of 1? So I was using decimals. If we cannot figure out from the decimals, then we have to plug in, right? So f of 1 in that case, f of 1 equal to 4, 1 minus 1 squared. Then we get, there's a 3. So 3, yeah? F of 2, we're using functions, so 4, 2 minus 2 squared. Then we get f of 2, which is 4. So we have a 7, right? Okay. How about second one? Second one, I made a really nice picture as well. Okay, they say that left hand endpoints. So we have width equal to 1, right? So left, so we start to left, yeah? And then this is also left. Um, okay, so I think the picture is not clear, huh? So because we have a left hand endpoint, so left, so start the left hand, right? And left hand, and then width is 1, so we can stop here. Or if we can more rectangle, but that's not the left hand, yeah? Because we don't need a 3, right? So not necessary for this one because left hand. Okay, so area equal to width times height. Width in the case is 1. Height is f of 0 plus f of 1. That's it, because the left hand point. So we have this, we have that, right? Okay, then we get 1 f of 0, which is 0, and plus f of 1, which is, we have 3, right? Which is 3. Is okay? All right. Next one, we have oil import. So we have this one. Yeah. Okay, now. We want to make n equal to 5 intervals. And left hand endpoint. To estimate the area, the graph from 2014 to 2024, give an exact answer, do not round. Okay, so let's take a look. We have x-axis, which is 2014 to 2024. So the interval, how do you make an interval? So 2024 minus 2014 over and 5, n equal to 5, so 5. Yeah. So there. Okay, then we have 2. That will be width. Okay, let's draw here. Start 2014 and 2 years for the interval. So okay, let me pause. Okay, so I drew the rectangles here. All right, so left hand endpoints. So there will be this one, this one, this one, this one, this one. That's it, right? In rectangles. Okay, so we have a width is 2, so area equal to width times the height. Width, which is 2, so we factor out. The height is f of 2014 plus 2016 plus 2020, 18, 2018, 2018, and plus 2022. So 20, sorry. And the last one, 22, right? Okay, so there will be 2 times f of 2014, we using this one. So 219.5 plus 192 plus 191 plus 198.9 plus 214.5 plus 228.4. Okay, so we calculate there will be 2031.8. What's the unit? That's billions. Yeah. Billions of dollars per year. Billions dollars. Yeah. And the year is cancel out each other. Yeah. So billions. Okay, now what does this area represent in terms of US oil imported, right? So projected total spend on oil import for the period 2014 to 2024, right? So the third one, right? This is the total, not the average, right? Okay. Any question? Oh, you can ask. I'm sorry. All right. Thank you for watching. I think that's it, right? Bye.